Yeah, hello everyone. Myself Yadagiri, Faculty of Basic Electrical Engineering, MLR Institute of Technology, Hyderabad. In the last session, we have discussed about the superposition theorem and its procedure and how to apply the superposition theorem. So in this session, we are going to discuss about the numericals based on the superposition theorem. So in this, the first question and first numerical, the circuit shown below to calculate the current through 10 ohm resistor by using the superposition theorem. So here we have 2 10 ohm resistors are present in the network. So that we need to find out the current through this 10 ohm resistor. So by using the superposition theorem. So how to apply the superposition theorem means, if it is a network having the two independent sources, so we can simply connect one source and the rest of the sources can be disconnected. So if it is a voltage source, we can simply replace it by their internal resistance. If it is not there, we can simply replace it by short circuit. Then if it is a current source, we can simply replace it by open circuit. So there is a voltage source in the network, we can simply replace it by short circuit path. Then there is a current source also present in the network, we can simply replace it by open circuit path. So these are the prerequisites of this question. So now first step we need to go with the same superposition theorem. Now in the step number 1. So in the step number 1, what we need to do means, so 20 voltage source is acting alone. So according to the previous session, the same statement. So 20 voltage source is acting alone, and also disconnecting the 4 ampere current source, and also the 4 ampere current source can be disconnected. So we need to disconnect the 4 ampere current source, which can simply replace it by, so this current source can be replaced by open circuit. Then we got this step is going to be like this. So this is 20 volts battery connecting as it is, or 20 voltage source connecting as it is. So this is a 10 ohm resistor, and this is a 10 ohm resistor, and this is the 20 ohm resistor, and this is current, open circuit current source. So we can simply replace it by open circuit. This is a 5 ohm resistor. So this is 20 voltage source. So 10 ohm, 20 ohm this is. So here we have done the open circuit here. Means in the step number 1, we need to connect to the one source. We need to apply one source acting alone, and the other source can be disconnected. So this source is connected and the 4 ampere source can be disconnected, which is simply replaced by open circuit. So then we need to find out the current through this element. This corresponding 10 ohm resistor only. According to the question, we need to find out the current through, so this 10 ohm resistor only. So step number 1. So what we have done means, so we can simply disconnect the source 2, that is the current source, and we have keep the 20 volt source as it is. Then corresponding current through the 10 ohm resistor is, that is I dash, we can say. So according to the procedure, so first of all, what we need to find the current through this corresponding 10 ohm resistor. So before going to finding out that, so first we need to find out the total current of the circuit, that is I total equal to the, so V total upon R equivalent. This is the formula from Ohm's law. From Ohm's law, I equal to V by R. So it is only applicable for one element. So we have more group of elements are there. That's why I total equal to V total upon the R equivalent we got. So that is here the V total value is given. So that is I total dash, means source 1 is acting alone. We need to keep that I total dash equal to, so V total dash upon R equivalent dash. So this dash is clearly indicating us source 1 is acting alone. So here V total given, that is a 20 volts. Then divide by the R equivalent dash. So R equivalent dash we do know. We need to find out the R equivalent dash based on the network reduction concept. So the current given by the 20 volts is according to the notation, there is a I total dash. So it is coming from the 20 volts battery, and enter here and divide between these two. So based on this division, so the 10 ohm current is moving towards this bottom path and also leave by the minus terminal of the battery, and this current is moving towards this path and leave from this point. So in this entire analysis, this 10 and this 20 ohms are in series, and the combination is parallel to this 10 ohm resistor. So R equivalent dash of the circuit equal to the, so 10 ohms and 20 ohms are series. So 10 ohms and so 10 to 120 ohms are series. I mean, we can simply directly write that values are so 20 plus 10. So which parallel to 10 ohm resistor and which is in series to 5 ohm resistor. This is the R equivalent dash of the R equivalent of this circuit. So hence this R equivalent equal to 30 parallel to 10. So which is in series to 5. So here 30 into 10 upon 30 plus 10. So plus 5 we write as it is. So 30 to 10, then 30 into 10 keep as it is, then divide by 40 plus 5. So these two gets cancelled. The final R equivalent dash equal to the, that is a 7.5. So the resultant of this one, this is a 5. So therefore R equivalent to dash of the circuit is a 12.5 ohms. So this is way to get the R equivalent of this above circuit. So after this one, what we need to find out the total current of circuit based on the Ohm's law. That is I total dash equal to V total dash by R equivalent dash, which means 20 divided by the 12.5. So we got the overall current value of the network is a 1.6 ampere. So this corresponding 20 voltage source delivering the 1.6 ampere. So it would like to deliver the 1.6 ampere current towards the entire network. So based on this one, what we need to find out the I dash value. So the source one acting alone, I dash is nothing but it is a current flows through the so the upper 10 ohm resistor, that is 10 ohm resistor, upper 10 ohm resistor. So that we need to find based on. So this is I dash equal to the, according to the current division rule. So total current of circuit into same opposite resistance upon total resistance. Opposite resistance by total resistance. So I dash again simply, which implies I dash equal to the total current of circuit is a 1.6 according to this one. So the opposite resistance of here, the opposite resistance. So opposite resistance of then this 10 ohm is opposite resistance. These two are divide the current. I mean this entire branch and also this 10 ohm is both are opposite together. Means we got here 10. So divide by total means so 10 plus and again 10 plus 20. So total means these two combination only. Why? Because these two branches are participating in the current division. That's why the total resistance of the, so this term is which one? 10 plus 20. So therefore I dash value equal to the, so that is 16 upon, we got finally 40 in the denominator. So that is 0.4 ampere. So the current flows through the 10 ohm resistor while connecting the 20 volts battery is 0.4 ampere. This is the step number 1 by using the superposition theorem. The step number 2, the same method we can repeat for the above circuit. Means now we need to connect to the 4 ampere source alone and the voltage source can be disconnected, means which can simply replace it by their internal resistance if it is present. So there is no internal resistance present in the network, that's why we can simply replace it by the short circuit path, that is. So the corresponding current through the which value, 10 ohm resistor is so that is, so this one given the notation as already in the question, that is I. So source 2 is acting alone, that corresponding value is we can take it as I double dash this is. So then I double dash equal to the, so according to the previous method, Vt double dash upon R equivalent. So this is the formula actually according to Ohm's law. But the corresponding source in the network should be the current source. We no need to again calculate the current value. So that directly I total double dash equal to the 4 ampere. I total double dash value is 4 ampere. So this is the I total double dash. Then we need to find out the current through 10 ohm resistor. So from current to division rule, so the current through 10 ohm resistor, that is I double dash equal to total current of circuit into same as opposite resistance, same as the opposite resistance upon total resistance, opposite resistance upon the total resistance. So which value is I double dash equal to the, so the total current of circuit is this one, that is IT double dash is the which one, this is the 4 into, so opposite of this 10 is the which one, 20 divided by 10, 20 plus, then sorry 10 plus, so this also participated in the current division, but so this combination is parallel to 10 ohm resistor, so in the denominator we will get this combination also, that is 5 parallel to 10. So the current flows to this element equal to the, that is the total current of the circuit into, so opposite resistance by opposite resistance of the 10 ohm resistor to the total resistance of the circuit. So that is, so current flows to this value equal to the, so 4 into, so 20 is the opposite of this one, I mean 20 only divide the current along with the 10 ohm resistor, that's why, so 20 upon the, so 20 plus 10 plus, and the combination of these two. The combination of these two is the 10 ohm resistor is a, so parallel combination of the 5 and 10, that is, so 20 plus 10 plus 5 parallel to, that is 10, 5 parallel to, that is 10. So this is 10 ohm only, so that this is a 10. So the resultant value is, so 20 into 4 upon, so this is a 20 plus 10 capacitors. So instead of this we will get the value is, so that is a 10 into 5 upon 15, so which equal to the 80 upon the 30 plus, so 3.33 finally we got. So therefore the overall value of, I mean the current flows to the 10 ohm resistor by 4 ohm connecting alone, by 4 ohm acting alone, otherwise 4 ampere acting alone. So I double dash equal to the, so 80 upon, that is a 33.33 we got finally. So this ratio will give us the 2.4 ampere current. So therefore the current flows to the 10 ohm resistor is a I double dash, we have given the name, that is 2.44 ampere, I mean simply 2.4 ampere. So this is current flows through the 10 ohm resistor while connecting the 4 ampere source. So is that enough to get the value? No, means we need to find the overall value of the 10 ohm resistor from the two sources are connecting to the whole network. These two sources are connecting the network. So that corresponding entire value is I equal to the, so that is I dash plus I double dash. So the I dash is the, so 20 volts source is connecting alone. This is the I dash value. The I dash value we got as 4 ampere. This is delivering the current towards the left to right, I mean starting to ending of the circuit. So that is a 0.4 capacitors. Then plus, so this corresponding current 4 ampere source current delivering towards the 10 ohm resistor should be, that is again right to left side. That means, so we need to get the here minus here, I mean minus 2.4. So therefore overall current through the 10 ohm resistor is a minus 2 ampere. So this is the current to, so flows towards the 10 ohm resistor. So this is the way to apply the superposition theorem. So this question given in the I mean in this question we need to find out the current flows to the 10 ohm resistor by using superposition theorem. So before going to apply superposition theorem, we need to determine the number of independent sources. We have done that is, so 20 volts is the one independent source and also 4 ampere source is the another independent source. So we need to follow the step by step. So in the step number 1 we need to disconnect the source 2 and which can be replaced by their open terminal, means there is no presence of the internal resistance of that corresponding source, so that we can simply replace it by the open circuit because it's current source. Then after that we have find the current flows through the entire network, and after that find out the required current flows through the 10 ohm resistor, this 10 ohm resistor. That value we got it as 0.4 ampere. Then after that we need to go through the second step, that is, so source is connecting alone and the remaining source can be disconnected, that is voltage source can be simply replaced by the short circuit path, that is, so this we got like this, and the corresponding current value of the 10 ohm resistor is a minus 2.4 ampere. And the whole current while connecting the, I mean both sources are acting simultaneously, the corresponding current flows to the 10 ohm resistor is that is minus 2 ampere. So this is the answer given about the, answer got about the given question. So this is the end of the session. So thank you one and all. Thank you for watching this video. So in the next session, we are going to discuss about the further network theorem, that is the Thevenin's and Norton's, and also the maximum power transfer theorem. So thank you one and all. Thanks for watching.